So شباب, for the single phase induction motor, we will just start the remainder few minutes discussing some information about single phase induction motor, and we will continue our discussions inshallah in next classes. Firstly, the objectives of discussing the induction motor شباب, we need to discuss the construction of single phase induction motors, the operation of single phase induction motor, how it works, the theory of double rotating field. What's the meaning of double rotating field? Recognizing the problem of induction motor starting. Do we have a problem in induction motor starting and how we can solve that problem? Discuss the methods used to start single phase induction motor. So it seems that there is already a problem in starting, and we need to discuss different methods used in starting the induction motor. After that, we need to drive an equivalent circuit for the motor. This is to make mathematical modeling and try solve some problems with this machine and analyze the motor and observing the response or performance of that machine. Also, we need to discuss the power flow of single phase induction motor, and finally, parameter determination using no load and load rotor test for single phase induction motor. يعني last objective may not be included in our classes if we took more than usual time in our classes, but if we have time we will discuss it inshallah. So last one is optional. So let's start in first an introduction to single phase induction motor. Single phase motors are small motors, so we use it for small power application. This is for single phase motors, not only for induction, for any other single phase motor. We just discussed the universal motor and we said we use it in small power applications. And similarly, any single phase motor is mostly built in the fractional horsepower range. This is because of the small rating loads we needed in domestic loads, for instance. Most of loads at homes are in range of fractional horsepower. So we need this motor or this type of motors, single phase one, for the small power application like in domestic loads. They provide motive power for washing machines, fans, refrigerators, hand tools, record player, joist maker, and so on. So all of the kitchen machines are using single phase motors. Again, we're discussing the general single phase motors, not only single phase induction. Also, single phase motors are or have three different types, mainly three different types. However, you may find any other classification based on something else, but in this classification here, we will classify the single phase motors into three categories. First category is the single phase induction, and this is what we are going to discuss inshallah during this topic. The majority of fractional horsepower motors are of induction motor type. Why shabab induction? Because it's very easy to be controlled and also to be manufactured. The rotor is very easily designed and manufactured in workshops or in factories, okay? And also they are classified according to the methods used to start them. We said that we have a problem in starting DC motors, single phase induction motors, and there will be some methods used to start them. The motor name will have the same name of starting method. So for instance, we will make a split phase start, so we will have split phase induction motor. We will have capacitor start motor by using capacitor in starting only. So we will have a motor called capacitor start induction motor. We will have something called the capacitor run, and we will have one called shaded pool induction motor. So all of these are types of induction motors, single phase one, and the name of the induction motor here is given with the name of starting method. Also we have single phase synchronous motors. طبعا synchronous motors, it has the advantage of constant speed. So whatever the load torque, the speed will be constant. So we use it also a lot in fractional horsepower motors, which needs a constant speed. So motors of synchronous type run at a constant speed and are used in applications such as clocks. And you know, clock has to move in the same speed, otherwise it will be a problem. Also, two types of single-phase synchronous motors are in common use, which are reluctance type. But take care, there's a difference between reluctance synchronous machine and the switched reluctance motor. These are two different motors. So reluctance one, we mean by reluctance as synchronous reluctance. And one is called hysteresis type. Unfortunately, we don't have time to discuss these two types of synchronous motors in our classes. However, it's used in our applications, but not commonly used like single-phase induction motor. For that, we will focus on the most one used in industry. Also, Shabab, we discussed or we have single-phase motors like universal motor, or sometimes we call it as AC commutator motor. We said that in our discussion in universal, okay? And you can find this name in many books, Shabab. AC commutator motor. It's the same. It's meaning that motor is universal type. طبعا motors of series type, I mean for DC, can be used with either DC supply or single-phase AC. This is what we have discussed in universal. These motors provide high starting torque. This is the advantage, and can operate at high speed. So these are the main advantage of universal motors. It's working with high starting torque, as we discussed, and also high speed. We could see that speed can reach to 10,000 RPM or more, be higher. They are widely used in kitchen equipment, portable tools, and vacuum cleaners, where high-speed operation permits high horsepower per unit motor size. So these are the three types of single-phase motors. So we discussed recently the universal motor, and we could see that it can be also working as a single phase. However, as you remember, the single phase or universal motor, we have two windings, one on the rotor, and it's called armature winding, and another one on the stator, and it's called the field winding. And both of them are connected in series. However, in single-phase induction motor, we don't have any windings in rotor. The rotor is only squirrel cage. And we discussed previously squirrel cage induction motor for the three-phase. It's similar like in three-phase, Shabab, where we have cage with internal bars. طبعا here it's written plus or minus. طبعا it's, dot or cross. It means that the current is moving like that. Okay. So this is according to the equipment of flux, Shabab. The current will rotate in different way according to the flux under board. So we have one winding for stator and bars in rotor. Motors of induction type have cage, rotor, and single-phase distributed stator winding, like what we could see here. Such a motor inherently doesn't develop any starting torque. This is a big issue here, Shabab. The starting torque is zero, and therefore will not start or rotate the machine if we supply just by AC supply. However, if the rotor is given a spin, just if you make a spin for the rotor, but even by your hand, it will start the Shabab. Okay, it will start. So this means you need something at starting to build a torque component or flux component to start the operation of the machine. طبعا we will discuss this in more details. So this is the shape, Shabab, of the motor. This is the rotor type. This is here the stator core, and inside the stator core we wound our stator windings. By the way, there will be two different windings will be used. One is called the main winding, and another is called auxiliary winding. We will discuss this inshallah in details. However, firstly, we need to understand why the motor cannot start in the beginning. There is a theory discussing this issue. It's called the double rotating field theory. I will hint only this derivation, and we are not going to drive the equations in details, but we had a drive like that in the beginning of three-phase and synchronous and induction motors. It's the same equation. You know, the MMF of the single phase of the machine can be calculated as Ni cosine theta. N, which is the number of turns, I is the current moving, and the cosine theta, where theta is the angle of the axis of the main winding. So if we have certain number of turns and we apply a certain current for the machine, the MMF of the machine can be calculated as f of theta and t equals Ni maximum cosine theta cosine omega t. Cosine theta, which is the function here, cosine omega t, which is a part of current. So this is now the equation of the MMF. Now we can substitute the value cosine by different equation. So we can make the equation to be like that, Ni maximum over 2 cosine omega t minus theta plus Ni maximum over 2 cosine omega t plus theta. Omega t minus theta and omega t plus theta, شباب, this means that we have two flux components, not only one flux. One is moving in a direction of theta, and another is moving in a direction of minus theta. So we have something called forward flux, and another one is called backward flux. When both of fluxes should have, this is firstly the rotating vector of each component of flux. So if both of them are in phase in the beginning, okay, so the resultant flux will be like that. And if they are moving in opposite directions, so the resultant will be like that. However, if both of them are in opposite to each other, the resultant will be zero, because they have the same magnitude. And unfortunately, this has happened here at the starting. For that, the summation of the flux of the motor at starting equals 0, and the torque as well equals 0. So the first characteristic here, شباب, this dashed one, is for forward torque versus speed, and the other one is for backward torque versus speed. The summation of the two torque components will be the bold one, the solid line here. And as you can see, for this solid line, at starting at 0 speed, the torque equals 0. For that, the motor cannot start by supplying the machine by AC supply like that. However, if you just give a spin by your hand to the motor to start, it will move in any direction. It's up to your stem. So if you spin the motor to move in that direction, it will follow that direction and continue working up till reaching the operating point, and it will continue at the operating point. Or if you make the spin in the reverse direction, it will take the reverse direction here and will continue moving in that direction. Okay, شباب? So this is just a brief about the starting problem and the double field theory of the single phase induction motor. Inshallah, next class we will proceed more in this theory and we can see how we can solve that problem. Is there any question, شباب?
Doctor, is there another method, like spinning the rotor?
طبعا spinning the rotor is not a method. I mean, if you do that, it will operate the motor. However, to be honest with you, we have some loads like that in our life. You know, sometimes in boats, okay, sailing boats, شباب, sometimes you can find motors at starting you have to draw a wire in order to operate the motor in the beginning. This wire, when you draw this wire, it just makes a spin for the motor to start rotating. So it's used already. However, it's not preferred because we have many techniques or many automated techniques that can be used. يعني which is considered as يعني customer independent. يعني you shouldn't ask the customer to do something in order to operate the motor. However, you know, for simplicity, even in some workshops يا شباب, if we use one of the automated solutions and the automated solution failed to work for any reason, maybe if we use capacitor for instance, maybe the capacitor lifetimes ended or damaged or anything, so they make it manually يا شباب. So they just start the motor manually to يعني ايه, to avoid paying a lot of money in such a solutions. Okay. However, يعني mechanical spinning like that, it can be used. Okay. Any other question, شباب? Okay. See you inshallah in the next class. Yeah. السلام عليكم ورحمة الله.
دكتور.
Yeah. تفضل يا شباب.
Actually, I have a question in the